Afternoon, guys. Welcome back. And this is the last of our lab lectures the last lecture for our lab. So this is for Virtual Lab 11, Colligative Properties. So we'll talk through that. I'm going to go ahead and share my screen so that you can see what we're talking about. Now, this particular experiment, there's a lot of steps to it, but it's not particularly complicated. One thing I will say about this particular virtual lab is that it actually works way better than when we do it in the physical lab. And so I'm actually very pleased about that because it allows you to actually see the effect that we're trying to talk about. And this is one of the last topics that we talk about in the class, and that's colligative properties. And colligative properties are based not on what the actual substance is, but how much of it there is. And that specifically means how many ions. So we have this thing called the Van 't Hoff factor, which should describe the number of ions that we get from each particular thing. So I know that CaCl2, when it comes apart, should become a Ca2 plus and 2 Cl minus. So I should have 3 particles that come from that. And one of the things that we're just trying to do here is to determine if experimentally it appears that the Van 't Hoff factor is actually 3, which in my calculations, it doesn't. You're going to do this experiment 3 different times. There's a ton of data that you're going to collect, and then there's a ton of calculations. Now, one of the things that I want to say about those calculations is that there are detailed descriptions of and examples of these calculations in the Calculate the Van 't Hoff factor little sheet that's down there. One of the things that I found that even though I knew what I was doing, found very confusing is that when we get to the mass of water in grams, which is one of the things that you're asked to calculate, it says the mass of the water added plus the mass of the ice melted, and then it lists all these numbers down here. So all of those numbers that are listed there are actually related to numbers that they've already done. So the mass of water in solution is equal to the mass of the calorimeter plus the solution, that's this first number right here, minus the mass of the calorimeter, that's the second number right here, minus the mass of the solid that you added to it. And then you add to that number that you just calculated. You add to that the mass of the melted ice. Okay, so that's what that calculation actually looks like. And once you understand that those are all the pieces to it, it should be fairly simple to do. I'm a big fan of Excel, so once I set up one of these calculations and I understand it, I just copy and paste if we're going to do it again, and then I know exactly what I'm supposed to be doing. So that way, when I am doing my experiment and I have these data points that I've taken, I can put them into the Excel sheet that I have and have it calculate what it needs to calculate from those values. So this is the Excel sheet that I set up. And all of the numbers that are here, all these things that are in red are calculated. So that's stuff that had to be calculated based on the numbers that were put in. So as I collect my data in my lab notebook, I also put it in here so that I can do those calculations. Now, if you don't speak Excel, that's perfectly fine. You can do these without this. And of course, in my lab notebook, I have a recording of all of the calculations that I did handwritten so that I know what I'm looking at. That's how I can explain to you exactly what I did in that one calculation. The only other thing that I think is a little bit confusing, you are given a formula for the Van 't Hoff factor in class, or for how we calculate a freezing point depression. And that's different than what we're doing here. Okay, so it's not going to be the same formula. So remember to follow the instructions that are here for calculating the delta TF, which is the initial minus the final. Okay, so it's going to be bigger than you would expect. Okay, because we usually start in the positive and then subtract a negative, and so it ends up being a little bigger than we would have expected. We're not looking for the final freezing point. We're not looking for the freezing point depression. We're looking for the actual change overall. Okay, and then the calculating the Van 't Hoff factor here requires a graph to be generated, and the graph, that slope divided by the KF value, which is given to you, okay, is actually 1.86. Okay, so the slope divided by that 1.86 gives you the apparent Van 't Hoff factor that you need to report. Okay, I think that's everything you need to know. Um, Again, not a huge deal. I To me, all of the number of sig figs here felt sane for once, and so I thought that was good. But that's everything I've got to talk about with this. Just follow the instructions as they're written. Make sure you do everything it says, because otherwise it's going to call you out on it. Like if you forget to put the calorimeter in the waste container, it's going to say, "Hey, wait, you didn't do that." So make sure that you've done everything. This is one of those ones where as you go through each step, it does not check it off. It only does it when you try to go to the next phase. So if there's anything you missed, you'll need to go back. And also remember that with these labs, when you get to the end, if you didn't get 100%, you can always go back, find what you missed, and fix it. Or you can do the whole lab again. Either one is perfectly fine. All right. Well, I think that's everything I have. Thanks a lot for joining me. I hope that we have a good time for the rest of the semester, and I will be following up with you guys via communications with the announcements and emails. Thanks. Have a good semester.